All right, in this video, we're going to talk about the tangent ratio and how it's related to slope. So just a little reminder here, anytime you have a triangle and we want to calculate the slope, remember it is change in y divided by change in x. And it's from this angle here, we'll call that the reference angle. So change in y divided by change in x. That is our slope ratio. And so we have this tool here on Desmos that helps us figure out what the slope is for really any sized triangle, because we're working with similar triangles in this unit. So we want a slope ratio for all of these angles here. We'll go ahead and type them in. So our slope ratio, we're going to start here just with our basic 45-degree angle. So if this angle here is 45 degrees, you're noticing that these two sides here end up being equal to each other. And the reason they're equal is, well, we have 45 degrees. This angle would also be 45 degrees. This is what we call an isosceles triangle. So if I were to divide these two sides with each other, 10 divided by 10, I would get a slope of 1, a ratio of 1 is what it would simplify to. So let's try moving that all the way down to 11 degrees. You can see how the triangle changes. This is really just a triangle creator where I can change the angle while keeping this a right angle here. So these are all similar triangles. So now our ratio is 0.194. That is what I would get if I divide my change in y with my change in x, 0.194. Let's create the 28-degree triangle. Let's move this to 28 degrees. And the ratio I would get when I take my change in y divided by change in x is 0.532. And again, that number is not going to change as I make the sides larger because they're going to grow proportionally with each other. Okay, so 0.532 is what we would round that to. Our 32 degrees, the ratio, as you notice, is getting larger, 0.624 would round to 625. I always do 3 decimals, 0.625. Now we're going to increase to 50 degrees. Oops, 50. And we see that our ratio is increasing even more. 191 would round to 192, 1.192. And our 56 degrees is going to be 1.482, which would round to 483, 1.483. Now what I can do is I can use these ratios to help me solve for the problems down below here. Okay, so these are all right triangles. And I know that what I get when I divide these two sides needs to be equivalent to whatever number it matches up with in this diagram here. So we've got our 28 degrees. That's going to match up with this decimal. What I get when I divide these two sides, it needs to equal this number here. So let's go ahead and try to set that up. So I would say, okay, that decimal, let's take that decimal, 0.532. I need to equal that to y over 12 because these triangles are all similar. So if I were to do a cross product, I could get y times 1 is y, and then 12 times 0.532. Now for my approximation, I can just put this into our scientific calculator, 12 times 0.532. And we've got 6.384, 6.384. Okay, let's try that one more time. So the number I get when I divide these two sides has to be the same ratio as our 50-degree angle here. So this needs to equal 1.192 when divided, because it is similar to a 50-degree triangle that also has a right angle. So we can say, okay, well, that decimal, 1.192, that needs to equal 22 divided by x. Now I'm going to actually have to do a cross product here where I get x is going to multiply to that 1.192, and then it's going to equal 22. So for this one, to get x by itself, it's being multiplied by that number here. I got to divide by that. So x is going to be approximately 22 divided by 1.192. And be about 18.456. 18.456. Okay, I'm going to let you try this one on your own. So the y divided by 10, what value in our chart does that need to be equivalent to? Okay, and now we're going to see, okay, well, what is the connection? So let's just check our first problem here with the 28 degrees and the 12. So let's see if we can create that actual triangle. So 28 degrees, and we want this side here to be 12. And we got a solution for this change in y side of 6.380. Let's just make sure. And we've got 6.384, yes, just a little rounded off, okay? So we created that triangle. Now I wanna show you, well, there's a special button in your calculator. So we might not always have this tool where we can change the angle, where we can change the side length. We might not always have this tool, but a tool that we do always have is something called a scientific calculator. So let's look at this number here, 0.531. On your scientific calculator, there is a number, or there's a button here that represents that slope ratio, and that's called tangent. The tangent of 28, look, it's the same exact number, 0.5317, et cetera, et cetera. The tangent of 28 is really just the slope ratio. When we look back here, we've got the same decimal value, tangent of 28 equaled this number here. So instead of using that decimal, what we could do instead is we could say, well, that decimal, a more accurate answer, this decimal here is really the same value as tangent 28. That's really what it is. And all of these here, so this would really be another value, we would call it tangent 11, or this would be like tangent 32, or tangent 50, or tangent 56. Okay, so what we could do in our calculator is say, well, what we get when we divide these two sides, it really needs to be this thing that we call tangent of 28, which is the ratio of what we get when we divide those two sides. Okay, so if we were to set this up in our problem, if we changed this decimal value and we replaced it with tan 28, well, I would get 12 times tan 28, and let's see if we get the same answer. And look at that, we're getting, so we have here 12 times that decimal value, but instead we said, oh, well, a more accurate answer than that decimal that we rounded is this tangent 28. And you're noticing that they're essentially equivalent solutions, right? This one is actually a little more accurate than that. So now, instead of using the slope ratio tool to create triangles, we're going to move directly to the calculator, okay? So in the calculator, what we want to be able to identify is we always want to be able to identify, okay, well, what's change in y divided by change in x? Well, instead of calling this side change in y, because the triangle might not always be drawn in that order, I'm going to call this the opposite leg, and I'm abbreviating that, opposite leg. And then I'm going to call this side the adjacent leg, adjacent leg. So opposite is next to, opposite is across from the slope angle. Adjacent is next to, okay? So what you want to do is from this reference angle, we call that theta. We have this side here opposite to it. So I'm going to put an O next to this side for opposite. And this leg here is an adjacent leg. Now this side's the hypotenuse of the triangle. We're not using that for this lesson, at least, okay? And so we have here opposite leg, and this side here adjacent leg, opposite and adjacent. And you're going to do that for each of these triangles, because really what that's going to tell you is, okay, when I divide these two sides, it's always opposite over adjacent. Really, this triangle is just kind of a flipped around slope triangle. Or for this one, it's opposite over adjacent. If we were to redraw this triangle, it would look, if we were to redraw it as a slope triangle, that would be the theta degrees, this would be opposite, this would be adjacent, and then we'd say, oh, I know how to divide these two sides. I know the proper way that I should be rotating it to divide it. So instead of having to redraw it every time and rotate it, we're just going to label it with opposite and adjacent because we know those are the two sides that need to be divided. So then when you're kind of practicing here with these problems, we can say, okay, from 26 degrees, that angle here, this is the opposite side. It's not next to 26 degrees. This is the adjacent side. It is next to. So we would do tangent of 26 equals y over 20. Or on this one, it's kind of a flipped around slope triangle. So this side is opposite. This is adjacent. Opposite over adjacent. Here from our 26 degrees, we've got a lot of 26 degrees. These are all just kind of rotated around. We've got 20 and we've got V. This is opposite and adjacent. And then our last one here from 63 degrees, this side is next to it. This side is opposite to it. So remember, so it's opposite over adjacent. And then we just set up our ratios. We know tan, that tangent value of 26 degrees needs to equal whatever was the opposite divided by whatever was the adjacent. Oops, sorry, we said the adjacent on this one is 20. So you're going to set up a ratio for each of these. We could just say, okay, y would multiply with 1 if I did a cross product. 20 would multiply with tangent of 26. And then I would go ahead and put this in the calculator to get the approximation for that. So 20 times tan is 26. And that'd be 9.755 is what we would round it. 754 would round to 755. 9.755. Okay. And I will do one problem with you that has the variable in the denominator. So here we would set this up as tan 26 equals 20 over V. And you'll notice that these two problems actually look pretty similar. They've both got a 26-degree angle, but the location of the 20 is different for these problems. So now when I do a cross product, I actually end up with V multiplied to the tangent of 26, and that is equal to 20. And the only way to isolate that is to divide by the tangent of 26 on both sides. So this problem is going to be a division problem. So instead of multiplying, we go ahead and divide. 20 divided by tan 26. So here we multiplied, and then here we're going to do 20 divided by tan 26, and that would be 41.006. Oops, 006. Okay, I'll let you try these two on your own here. And then for question 6, just a reminder, our reference angle is changing. So we've got from that 32-degree angle opposite over adjacent. Create your ratio for that. From 56 now, or 58, the opposite and adjacent actually change. And I'd like for you to round this to the nearest whole number. Make it a little easier for you. And then when you get to this next question, it says find the length of the hypotenuse for this problem from number 6. So we do already know that this side here is 8. You were solving for this side here in both of these problems. And then let's call this side C. And what method you're going to use is Pythagorean theorem. Remember that this is another triangle tool that we know. So now we have the tangent ratio, which helps us solve for missing sides. And we also had the Pythagorean theorem, which works for right triangles when we know two sides and we want to find a missing side. And then lastly, this problem here, we don't know either of these legs. So this is a question mark. This is a question mark. We do know an angle and we do know a hypotenuse. Can't use tangent because we need a leg. Because if you remember, tangent is really the slope ratio. And with the slope ratio, we're using the change in y side and the change in x side. So we don't have the hypotenuse labeled. So with our tangent ratio, slope ratio, we cannot use it on this problem. We also can't use Pythagorean theorem because we need two side lengths that are known. So what that means is we will be learning how to set up this type of problem in the next lesson.